Increasing worldwide pressure for improvement in environmental conditions has required the state and private enterprise to take measures to bring development into line with limitations on the exploitation of natural resources. In the sanitation sector, domestic sewage treatment systems must be expanded in order to pay off part of society's environmental debt. The final residue of sewage treatment, known as sewage sludge, is semi-solid, viscous matter of a mainly mineral nature. The proper disposal of this residue is an important stage in the waste treatment process. However, it has been largely neglected since waste treatment projects in general completely disregard where solid waste ends up. At present, in most cases, sewage sludge ends up in sanitary landfills or dumps. However, such permissiveness in the use of landfills is soon to end with the enforcement of the National Solid Waste Policy. As from 2014, sanitary landfills will be restricted to the disposal of ultimate residual waste, or in other words, restricted to the disposal of waste that cannot be reused or recycled in any way. Thus, there is a need to find an environmentally correct solution that complies with legislation and yet does not overburden operating costs. Sabespi is a mixed capital enterprise responsible for the water supply and sewage collection and treatment of 363 municipalities in the state of São Paulo. In terms of the number of clients attended to, it may be considered one of the largest sanitation companies in the world. It attends to 27.1 million people. Sabespi's current treatment capacity is 44,000 litres of sewage per second. It is planned to implement this project at the sewage treatment plant in Barueri, which currently treats 9.5 thousand litres per second and can handle the sludge from other treatment plants. A viable alternative is to process this residual waste using the Senogen environmental solution. Instead of simply disposing of or burning biomass as a source of energy, as done in conventional technologies, the biomass refinery employs a correct sequence of processes that not only reduce pollution, but also extract raw materials of a high economic value. Low-temperature conversion, also known as LTC, is the technology proposed for treatment of sewage sludge. It consists of a thermocatalytic oxygen-free process that uses low levels of energy to transform the proteins and lipids of organic matter into oil and carbohydrates into charcoal that will be used to generate electric energy. The sludge used comes from the effluent not digested in the anaerobic reactors of the sewage treatment plant. This is called primary sludge and has the largest possible organic fraction. The sludge is discharged into a centrifuge and then dried in a rotating drum until it reaches a final humidity level of 10%. The already dried sludge is fed into the LTC reactors. During the conversion, the vapors and gases formed in the reaction are condensed and cooled. The aqueous fraction returns to the sewage treatment plant, while the oily fraction and the solid charcoal are stored in a specific area of the biomass refinery and later fed into a high-pressure boiler to generate electricity.